Jupiter, the largest planet in our solar system, is home to the most extraordinary storm ever witnessed, the Great Red Spot. This violent anticyclonic storm has been continuously raging for over 350 years and remains one of astronomy's greatest mysteries. The Great Red Spot was first observed in 1665 by Italian astronomer Giovanni Cassini and has been periodically monitored from Earth ever since. Early observations utilizing ground-based telescopes showed it spanned over 40,000 kilometers in width, wide enough to fit 3 Earths comfortably within its turbulent folds. But recent data from NASA's Hubble Space Telescope indicates this iconic storm has contracted dramatically over the past decade and a half, shrinking to a size just large enough to accommodate 1 Earth. In addition to shrinking, Hubble data shows wind speeds along the Great Red Spot's edges have accelerated by 8% from 2008 to 2020. The shape has also evolved from an oval in the late 19th century to a more circular formation during the 20th century, a process which continues today. Could the Great Red Spot one day disappear entirely? Detailed observations from Earth orbit have proven challenging, even for NASA's most powerful telescopes like Hubble. To truly uncover the secrets thriving within the churning maelstrom, NASA launched the ambitious Juno spacecraft in 2011. After a 5-year, 2.8 billion kilometer journey, Juno finally entered orbit around Jupiter on July 4, 2016. This began a series of close passes over Jupiter's cloud tops to unveil the giant planet's origins and evolution. Juno's science instruments are designed to see beneath the opaque clouds and unravel mysteries about the gas giant's composition, gravity field, magnetosphere, and interior. 2 teams of researchers have now used Juno's advanced instrumentation to reveal the Great Red Spot extends much deeper into Jupiter than expected, around 500 kilometers below the upper cloud deck. That is equivalent to the height of the International Space Station above Earth's surface. The first breakthrough came from measuring fluctuations in Jupiter's gravity field, caused by the Great Red Spot's massive presence. Although small compared to Jupiter's overall mass, these gravitational anomalies exposed the storm's towering vertical extent. The second team used Juno's microwave radiometer to probe beneath the thick clouds. They discovered evidence of intense precipitation and powerful updrafts at extreme depths, linking Jupiter's upper atmosphere to the deep interior below the clouds. Furthermore, the gravity and microwave data demonstrated the Great Red Spot is an anticyclone, spinning counterclockwise in opposition to Jupiter's clockwise rotation. Cyclones are warmer on top, while anticyclones exhibit the reverse thermal profile, with colder gases at higher altitudes. In addition to massive storms, Jupiter hosts strong east-west jet streams extending thousands of km deep, separating its iconic belts and zones. Juno detected winds reaching an astounding 3,200 kilometers deep, flowing in alternating directions within these jets. Ammonia gas appears to align with these jet streams, providing clues into their formation. Unraveling the mysteries concealed within Jupiter's atmosphere is key to understanding the early solar system's development. The gas giant contains pivotal clues about our cosmic origins. NASA recently extended Juno's groundbreaking mission until 2025, allowing continued observations from its polar orbits. As Juno's orbital path shifts, its gaze will turn from the Great Red Spot toward Jupiter's mysterious polar cyclones, arranged in a geometric formation unique in our solar system. Juno will also examine Jupiter's turbulent atmosphere, its hidden core, and its 79 moons, including the 4 Galilean satellites. Sending a spacecraft to withstand Jupiter's intense radiation and atmosphere was ambitious, but Juno's torrent of revelations makes the risks worthwhile. Each discovery brings us closer to fully comprehending the outer planets. The iconic Great Red Spot has inspired awe for centuries and harbors countless secrets within its folds. Piercing Jupiter's clouds is finally unveiling the true nature of this anticyclone. Measuring its height and probing its thermal structure paints a clearer picture of how Jupiter's atmosphere connects to the depths below. The revelations from Juno have been truly astonishing, revolutionizing our understanding of Jupiter and the enduring Great Red Spot. But many questions remain unanswered about the solar system's largest and most powerful storm. How did it form, and why has it persisted for centuries? What fuels its incredible longevity? One leading theory proposes that the Great Red Spot is powered by heat escaping from Jupiter's interior. The storm may be anchored by a stationary wave created from the internal heat flux interacting with the rapid rotation of the planet. This could explain why the Great Red Spot maintains its location while other smaller storms move across Jupiter. Scientists are using Juno's microwave radiometer and gravity data to model conditions below the visible cloud layers and test internal heat escape as an energy source. Early results suggest heat leaking from the deep interior may contribute to the storm, but is not the primary driver. The true energy source remains elusive. Unraveling the root cause of Jupiter's immense storms provides insights into similar phenomena on other gas giants. Saturn hosts long-lived storms like its hexagonal polar vortex, while Neptune and Uranus have their own great dark spots produced by massive swirling storms. Pinpointing the fundamental physics governing huge storms on Jupiter will aid understanding of atmospheric processes occurring on many planets beyond our own. Another mystery surrounding the Great Red Spot is how it has maintained its coherent structure for so long despite powerful winds tearing at the cyclone. Scientists theorize that the storm must extend to great depths in order to keep from shearing apart. Evidence of similarly stable storms existing below Jupiter's cloud tops reinforces this idea. Researchers also speculate that the Great Red Spot is comprised of many smaller structures that collectively maintain the overall shape. Data from Juno's microwave and gravity instruments have traced signs of numerous smaller weather systems flowing within the larger oval, interacting to uphold the anticyclone's stability. In addition to studying the Great Red Spot, Juno has made many other remarkable findings about Jupiter's atmosphere. The mission discovered that lightning on Jupiter is clustered near the poles, rather than distributed globally like on Earth. Lightning was also detected traveling up into the atmosphere, contrary to Earth's cloud-to-ground strikes. These patterns help paint a picture of Jupiter's turbulent internal dynamics. Juno also measured ammonia distributing heat across Jupiter's atmosphere during its early flybys, but starting in 2019, the spacecraft surprisingly detected an absence of ammonia gases around much of the planet. Scientists speculate ammonia may form an obscuring haze deeper in the atmosphere that blocked Juno's view. More flybys under different conditions can help reveal the complex behavior of ammonia. Sending Juno through the heart of the Great Red Spot could provide direct measurements of the storm's composition and wind speeds, which exceed 400 miles per hour at the highest altitudes. But this daring maneuver would place the spacecraft in grave danger from the intense turbulence and debris. NASA prioritizes keeping Juno safe for the remainder of its extended mission. Nevertheless, each close pass over Jupiter returns invaluable new insights that enrich our understanding of gas giants. Juno has already profoundly advanced planetary science, a legacy that will continue growing until its planned demise in 2025. When the mission concludes, Juno will dive into Jupiter's crushing atmosphere, capturing scientific data until the very last second. The enduring Great Red Spot remains one of the solar system's greatest wonders. Unlocking its myriad secrets is central to illuminating astronomy's most profound mysteries about the origin and workings of our spectacular planetary neighborhood. There is still so much left to uncover about the solar system's largest storm. As Juno's extended mission continues, we look forward to more incredible discoveries that will enrich our understanding of gas giants and planetary atmospheres. Be sure to subscribe to our channel, Spectic Cosmos, for the latest updates on Juno's revolutionary findings at Jupiter. We bring you the most interesting space and astronomy discoveries from across the cosmos. Hit that subscribe button and bell icon so you never miss a video. Let us know your thoughts on Jupiter and the Great Red Spot in the comments section below. We love interacting with our knowledgeable community. Until next time, keep looking to the stars and exploring the wonders of our spectacular universe.